company wishes to package 16 cubic inches of juice in a cylinder-shaped can. What radius will minimize the amount of material? Okay, so the volume of a cylinder is pi r squared h, and that's we're taking that to be 16 cubic inches. So if we solve for h, that means that h is equal to 16 over pi r squared. And then we also want the formula for the surface area. The surface area is going to have two different formulas. We have one formula for the sides, and then another formula for the top and the bottom. Well, the top and the bottom are just the area of a circle. That's pi r squared, but there's two of them. So that's going to be 2 pi r squared. That's for the top and the bottom, and then for the sides, well, we have the circumference of the circle multiplied by the height. So it's going to be plus 2 pi r h, and h we said was 16 over pi r squared. So we can rewrite this as 2 pi r squared plus 2 pi r times 16 over pi r squared. And then we can simplify it. The pi's will cancel and one of the r's will cancel. 2 times 16 is 32. So we're going to have, that'll give us 2 pi r squared plus 32 over r. Okay, or we can write that as 2 pi r squared plus 32 r to the minus 1. Okay. Okay, so then, so this is for r greater than 0. So this again is not a closed interval, so we can't apply our methods for closed intervals and just evaluate at the endpoints and the critical points. But we can, but if there's only one critical number, then that's going to be a max or a min, and we can analyze the sign to see if it's a max or a min. Okay, so let's take the derivative. So a prime of r is going to be 4 pi r, and this minus 1 exponent comes out in front, so it would be minus 32 r to the minus 2 power. And if we factor out, there's a common factor of 4, we can factor that out. And we can factor out the lowest power of r, which is r to the minus 2. So let's write this as 4 r to the minus 2, and then what's left is going to be pi r to the third minus 8. And if we let's factor out that the pi also. So this is going to be 4 pi over r squared r cubed minus 8 over pi. So that's that's going to be 0 when r is equal to the cube root of 8. We want to know when this derivative is equal to 0, and the only real solution would be the cube root of 8 over pi. So it's going to be r is equal to the cube root of 8 over pi. or you could write that as 2 divided by the cube root of pi. Okay, so then we want to analyze the sign to see if this is a min or a max. There's only one critical number here. So let's analyze the sign. Okay, so maybe I'll move this down a little bit. Okay, so at 0 this is undefined, that's the lower bound for the domain is 0, and then at 2 over cube root of pi, it's the derivative is going to be 0, and so we want to pick a number less than 2 over the cube root of pi. Cube root of pi is it's going to be let's see. Well, 1 cubed is 1. Let's see if we can estimate the cube root of pi. So 1 cubed is 1. 2 cubed is 8. So it's going to be pi is 3.14 approximately. So it's going to be between 1 and 2. The cube root will be between 1 and 2. Let's try 1.1. Is 1.21 times 1.1 again. And 3, 1. About 1.3. That's too small. Let's try 1.2. 2, 4, 1, 2. 288. 44. 8, 12. 7. Still too small. We'll try 1.3. 39, 13, 169, 93, 27, 18, 20, 5, 169, 7, 9, 11, 2. Still too small. Try try 1.5. We have cubed is 27 over 8. It's a little bit more than 3. Jump to 24. About 3.4. So it's 1.5 is pretty close. If we try 1.4, you get 696 times 1.4. 36, 38, 7, 96. Okay, so it's between 1.4 and 1.5. So so the cube root of pi we'll say is approximately, so 2 divided by the cube root of pi, let's say is approximately 2 divided by, let's say 1.5, and 2 divided by 3/2, 2 times 2/3, so maybe about 1 1/3. So we want to pick a number that is less than 2 over cube root of pi, and as a test point. So let's say 1 is certainly less than 1 would be less than cube root of pi, so we can use 1 as a test point, and certainly 2 would be more than more. So if we go, we put a 1 in here, we're going to get a negative number, and if we put a 2 in here, 2 cubed is 8, we're going to get something positive. So so the slope is oh, I didn't go back to this one here. So so if we're going back to our equation here, if we put 2 over cube root of pi is somewhere between 1 and 2. So if we put 1 in here, we're going to get something negative. And if we put a 2 in there, we'll get something, 2 cubed is 8, 8 minus 8 over pi is going to be positive. So the slope is going to be negative, positive, and negative 0, and then positive. So this is going to be a local minimum, and because it's the only one, it'll be the absolute minimum. So the solution is going to be r is equal to 2 over cube root of pi. The radius that will minimize the amount of material is a 2 over cube root of pi. Okay, and that concludes this presentation.